Hey guys, we're going to do another chapter 3 video here, and for this video we're going to do something a little bit different. You're going to need your student journal. So hopefully if you're watching this video, you're in my class and have a journal that you can use. If not, you'll have to kind of just follow along. So if you need to, pause the video, go grab your journal if you don't have it on your desk, and we're going to jump in to this page 79 in your journal. Okay, so what are we going to do in this section of our journal? Well, we're kind of getting towards the end of this chapter, the end of this unit, and we're working on graphing lines. We've watched some videos on how to graph in standard form, and we're going to kind of continue off of that. So the title of this says Graphing Linear Equations in Slope-Intercept Form. Put a box around that word, slope-intercept form. Every time I read that, I know it really means y equals mx plus b. Slope-intercept means I have the slope and the y-intercept. So that's the m and the b, y equals mx plus b. And preferably, this is my favorite way to write an equation of a line because y equals mx plus b is very easy to graph. So we're going to look at this first exploration, which has a graph already made for us. You can see the line right there. And what we're going to do is kind of study the slope of this line. So to do this, I'm going to circle some key points, and I want you to do the same thing. I'm going to circle the y-intercept, which I see it happens at 2, and I'm going to circle the x-intercept, which hits the x-axis at what looks like, I would say, -3. So I'm going to label those points. The y-intercept happens at 0, 2, and the x-intercept happens at -3 and 0. Oh, hi, Max. You're going to come be in the video, buddy? Oh, come here. All right. So kind of continuing on here. So we've labeled our points, x and y intercept. Now what we're going to do is make what we call that growth triangle. We're going to look at what is the steepness of this line by making that triangle. And we measure that triangle as what we call a rise and a run. Or sometimes we say delta y, delta x. So here's our rise, which is delta y. It's the change in the y values. Remember that symbol, delta is that Greek symbol. We've seen it in some other videos, so that's probably not new to you. And you can say change in y or delta y. You can use either word. You can kind of go back and forth. So you choose which wording you want to use for sure. And then if we're studying the change in the y, we have to measure it on the graph. So the run, we're going to do the same thing. The run is what we call our delta x, our change in x. And so if you count it carefully on the graph, I got delta y equals 2. Looks like it's going up 2 units. And it looks like delta x runs across 1, 2, 3 units. So I'm seeing a 3 and a 2. Is that what you see also on your graph? Hope so. A 3 and a 2. So we're going to write that fraction now, that slope fraction, where it's delta y over delta x. And in this case, it's 2 over 3. Totally makes sense because what was our equation of our line? It was y equals 2/3 x, 2 over 3. So that rise and run shows up right there. Why don't you try? Here's the second graph, part B. Pause the video and see if you can make your growth triangle and find your slope. Oh, Max. All right, you ready to check your answer? All right, so you had to circle 2 points to make that growth triangle. I'm going to use the x and the y-intercept just like I did in the previous example. So I circled the x, circled the y, but I decided those were really close together, so I decided to use 2 points that were a little bit easier for me to find that slope growth triangle. You can pick any 2 points that you want. So I picked where it kind of meets these lattice points. And because the line's going down, when I measure that delta y, I have to think of it as a drop down. It drops down 2 units. That's a -2 drop, and it runs 1 unit over, so that's a +1 run. So my delta y, delta x fraction is -2 over 1, or just -2. And that matches what we have in our y equals mx plus b. Y equals -2x. It matches up with that. It should match up with that, or something's wrong with our equation. So yeah, so how'd you do? Did you label everything kind of the same way I labeled? Did you get the negative slope? Did you use your delta y, delta x? How are you doing on this? Okay, I'm going to try another one. So for the next exploration, here's what you're going to do. You're going to pause the video and you're going to complete this table and the 4 graphs that you see. Then you're going to answer question number 3 with part A, B, and C. So you have a little bit of work to do. I'm expecting this will take you at least 10 minutes with a paused video to try to work through this. But we're getting towards the end of the chapter. This is your opportunity to kind of practice and see if you're understanding some of this stuff. So the first one's done for you. A, if you look in the table, there's an equation, y equals negative 2/3 x plus 3. Well, it's a line, has a slope of negative 2/3 and a y-intercept of 3. Your job is to go through and complete the rest of the table and the graphs and answer the questions. So hit that pause button, take about 10 minutes to work through this, and then we'll check some answers. Okay, so we're going to go through the solutions now. You should be totally done with filling out this table and doing the graph. So all of these are lines. They're all in y equals mx plus b form. Each slope is given to you by looking at the m value. So for B, letter B here, the slope is, it says 2x, so the slope is 2. For letter C, the slope says negative x, but that means the slope is negative 1. That's what really is there. And then for letter D, when it's just the x, well, what number is in front of the x that you really can't see is a 1. So that's a slope of 1. And then the y-intercepts are a little bit more obvious, that plus b. So for letter B here, we have a minus 2 y-intercept, and then for C, we have a plus 1 intercept, and D is a negative 4. So negative 2, 1, and negative 4 is what goes in your table. Now, here's what it looks like on your graphs. Each one of these should look kind of identical to mine. For A, we have to start way up here at 3 and drop down 2 over 3, down 2 over 3 for that slope. For B, we have to have a y-intercept of negative 2 and a positive 2 slope. So up 2 over 1, up 2 over 1. For letter C, we have to start at a y-intercept of 1. And then we have a slope of negative x, negative 1. So we're going down 1 over 1, down 1 over 1. Notice I'm always going to the right when I go over, never working backwards. And then for letter D, we start at negative 4 and we have a slope of 1. So we're going up 1 over 1, up 1 over 1. And hopefully your 4 graphs kind of match my 4 graphs. If not, pause the video and try to figure out where that mistake was. Now you had one more thing to do. You were supposed to answer question 3, part A, B, C. So let's look at that. A says, how does the value of m affect the graph in the equation? So m is that growth number, so it affects the slope or the steepness of your line. If you have a small growth number, then you have a pretty flat line. But if it's a big slope, you have a steep line. Or if it's negative, then you have a negative slope. So m affects the growth and affects the slope. How does the value of b affect the graph in the equation? Well, it's the y-intercept. So if b is the y-intercept, this affects where the line crosses that y-axis, basically. And then for C, your answers are going to vary on that one. I'm going to have to look in your notebooks later and kind of check those out. You guys could come up with a lot of different things on that. Okay, so for this piece, what we're going to do is we're going to get into just some note taking. So flip the page, find the page that looks like this. This is our vocabulary page. These are some words that we should be very comfortable with at this point. So we should understand what that word slope means. Slope is a measurement of steepness on a line. It often is called rate of change as you get into higher level math, but it's that measuring of delta y and delta x, that change in y and change in x. So big time knowledge here that you should have is slope measures the steepness of a line. And then rise is specifically the vertical change. It's the delta y in the slope. And then run is the horizontal change. It's the delta x in the slope. So we know that slope measures steepness. It's the rate of change in the line. We know rise is vertical. We know run is horizontal. Slope intercept form is just that y equals mx plus b. It's a fancier way of saying, hey, it's y equals mx plus b. And then that last little piece there where it says constant function, it's talking about lines that fall into this special category. Y equals 0x plus b or y equals b. These are lines that have a slope of 0, which means there is not really a delta y or a delta x. What's happening with those types of lines is they're flat. They don't have any steepness to them. So constant function is when you have a slope of 0 and you have a completely flat line. It's kind of a special case. Okay, so we got some notes here. Down below there's this section where there's kind of an empty note-taking space. And what I want you to do is in that space we're going to build a table. So we're going to make an XY table. So go ahead and make an XY table. And I'm going to make some numbers up inside this table. I'm going to tell you I have the numbers 3, 7, 15, and -5. So they're not in order. They're not my typical ones that I like, which is -2 to +2. But I happen to know that these points on the graph land at 2, 10, 26, and negative 14. Now, at this moment in time, I couldn't tell you what the growth is because these points aren't in order. I can't look for the growth value. It's very confusing. I could plot them on a graph. I could go ahead and graph these and see if it's a line. But if I told you I already knew it was a line, how could I find the growth of this line without graphing? Just on the table. Well, here's a strategy. What's the slope? Well, here's what I'm going to do. I'm going to pick 2 points in the table. Any 2 points that I want. I'm circling 3, 2, and 15 and 26. But I could have circled 7, 10, and negative 5 and negative 14. It doesn't matter. What I am going to do, though, is think of them as 2 coordinate points. So if I was to plot the graph, I would have a point at 3, 2, and way out at 15 and 26. And I know if I wanted the slope of the line, I would have to find what we call delta y and delta x. The change in the y's and the change in the x's. Well, look at the points. They're just x, y points. 3, 2, that's an x and a y. 15 and 26, that's an x and a y. So if I need the change in the y's, well, think of it like this. The first point, this is kind of new notation probably. The first point, I'm going to call it x1, y1. And the second point, I'm going to call it x2, y2. And I'm using the 1s and the 2s to show that this is the first point that I'm studying, and this is the second point. And we actually say x sub 1, y sub 1, x sub 2, y sub 2. It's kind of the opposite of like how you would write a power or an exponent. Instead of putting a little number up high, we're putting it down low. It's called a subpoint. So x1, y1, x2, y2. I'm going to study the y's first. Delta y is the change in y's. Well, look, y1 is at 2 and y2 is at 26. So the change, if I think about it, I could subtract the y's to find the change. I could subtract the x's to find the change. 26 take away 2 is going to be my change in y's. 15 take away 3 is going to be my change in my x's. So I'm going to end up with a change of 24 and 12. That means if I drew a giant growth triangle on the graph, it's going up 24 over 12. Oh, okay, well, what's 24 divided by 12? 2. My slope of my line is 2. M is equal to 2, and I figured that out without ever having to draw my graph. I found my delta y, delta x by finding the change in the y points and finding the change in the x points. So there's another strategy. And next chapter, we're going to become kind of masters at this strategy of how to find the slope without using a graph. So I wanted to introduce that today just so you get kind of an idea for it. All right, one more thing here. We have 4 different graphs that we're looking at in these pictures. Each of them represents different types of slope. The first one, these are all called the 4 types of slope. So the first one, our slope is positive. The line is going up. So that is an example of when we have positive slope. M equals a positive number. And then the second one's the complete opposite. We've got negative slope. The line is going downwards. So typically most lines either have positive or negative slope. But the other 2 types of slope that we could possibly have are kind of our weird cases. If we have a completely flat line, then there really is no growth triangle. There's no delta y, delta x. So we say the slope is 0. It's completely flat. But then the last case is a vertical line, a straight up and down line. Now think about it. Slope measures steepness. If your line is straight up and down, how steep is that? It's like a cliff edge. It's like amazingly steep. If I had to give it a number, it'd be really hard to do. So what we say is the slope is undefined. It's so steep, we can't give it a number. We can't define it. So slope is undefined. It's vertical. So those are the 4 types of slope. We have the traditional positive and negative slope. Then we have the weird cases where it could be flat and have a slope of 0. Or we have the super steep slope going up and down that we can't define. So we say it's undefined. Okay, so to end this video, you're going to finish page 83 in your book. I want you to work on problems 1 to 9 and really go through and practice this using the notes that we took in the video. And then when I see you guys in class, we'll have to check some solutions and see how you did on this. Thanks for watching the video. I hope you were able to kind of follow along, and I will see you in class. Bye, guys.